All right. Hey, some of you have asked for some extra help with the ratio word problems, a little extra opportunity to study these. So I've set this video up, and the way it's going to work is this. I'm going to walk you through the first two problems, and they represent two different types of problems. One of them uses all whole numbers. One of them works with some fractions. Then there are two more of each kind of problem on the rest of the video. So there'll be a total of 6 problems, 2 that I'm going to do as demonstration, 4 for you to practice. All right, so let's start. So Sam is in a cooking class. He's going to make, or he made 12 cups of a vegetable rice soup for the class. And when he made that 12 cups of soup, there were 2 different ingredients involved. There were 9 cups of vegetables, and there were 3 cups of rice. Put those together, the 9 cups of vegetables, the 3 cups of rice, and you get the 12 cups of soup. So he's going to make some vegetable soup for his skydiving team. He's going to use the same recipe. It was really popular with the cooking class. This time, instead of 12 cups of soup, he needs 16 cups of soup for the whole team. The question is, how many cups of vegetables will he need? So to solve a problem like this, we want to think first of, okay, this is a question about the vegetables. So what were the vegetables to the total in the original mix? Well, in the original mix, there were 9 cups of vegetables for every 12 total cups of soup. We know now that he wants a total soup of 16, and the question mark, the unknown right here, the X, is how many cups of vegetables will he need? And what this leaves us with is a proportion problem. We have 2 equivalent ratios. He's using the same recipe, so it's crucial to see that this is going to be the very same recipe used. So he's not changing things up, so we know it has to have the same proportions, the same mix. So when we do this, we have 2 ways we can solve it. One way is to look if 12 went into 16 evenly. We could just say, what are we multiplying 12 by to get 16? Since that's not the case, we're going to do diagonal multiplication. We're going to multiply the 9 times the 16 and the 12 times the x. So let's start with the 9 times the 16. And I'm going to bring a calculator down right over here. So we've got 9 times the 16, and that's going to give us 144. And that's going to equal 12x. Then the second part is divide by that 12. That 12 is the coefficient. It tells us how many x's there are. We know we have 12 x's. We don't want to know what 12x is equal. We want to know what 1x equals. So we divide everything by 12. And we find out that he will need 12 cups of vegetables if he's going to make a total of 16. Now, let's see if we can find a way to check that, see if that makes sense. Things we can do to check our work is to simplify those fractions. So what I can do is I can take the 9/12, simplify it, I get 3/4. Take the new 12 sixteenths, because we said x was 12, so 12 sixteenths. Simplify it. It also, I know my brain said write a 4, my hand wrote a 9. It also equals 3/4, and that tells us that we have equivalence. So in this case, Sam needs 12 cups of vegetables. So the answer right here, x is equal to 12 cups. Now the second question is part B, because this was all part A. This was all part A. The second part B, is how much rice will he need? We could go through the same process. We could do the very same thing. We could say the original recipe was 3 parts rice to 12 parts. What will x be to 16. We could do all of that. Here's the other thing we could do. We know that the soup is all vegetables and rice. So if he is going to make 16 cups total, and we know from our last part that 12 of it is vegetables, then we know that the remaining part is the rice. So whatever's left over in the soup mix, whatever isn't vegetables, has to be rice. And if we solved this, we would get the same thing. All right, so that's one kind of problem. Let's look at another kind. So now we've got you here, and he's in a canoe, and he's rowing 9.5 miles in 2.5 hours. And we want his average miles per hour. We call that a unit rate. What is his unit rate? Well, to get the unit rate, what we're saying is we've got miles, we've got hours. We know that he went 9 1/4 miles in 2.5 hours. This may be the first time you've seen a fraction made up of fractions, but that's fairly common in these types of problems. We have a lot of problems that don't work with integers. They work with fractional amounts or mixed fraction amounts. So we know 9.5 miles or 9 1/4 miles in 2.5 hours, and we want to know how much per hour. That's a 1. Now this problem is exactly like the one on top. As soon as we've set this up, it's like the one on top. The only thing you're going to run into is you're going to be working with these fractions. So step 1, we're going to cross multiply just like we multiplied on top. We're multiplying the 9 1/4 times 1. We're multiplying the 2.5 times x. 9 1/4 times 1 is 9 1/4. 2.5 times x is 2.5x. We're going to do the next step exactly like we did on top. We're going to divide by the coefficient. We're going to divide by 2.5. So we divide each side by the 2.5. That gives us 9 1/4 over 2 1/2 equals x. And we can't leave it that way. Let me just go back here for a minute. Remember, we got a big 1 right there, 1 times x. That's how we got that x. So we can't leave it in that form. That wouldn't make any sense. If somebody said, hey, how fast was you here rowing? Like, what was his miles per hour? And you said, oh, man, his miles per hour was 9 1/4 divided by 2.5 miles per hour. They'd look at you like you were nuts. So we have to take that a step further. So we're going to take that a step further. And we're going to remember that any time we are dividing with fractions or with mixed fractions, we don't divide, we multiply by the reciprocal. Now, we've got to take those two things and change them, though. We've got to change that 9 1/4 into a improper fraction. So 9 times 4 is 36, and 1 more is 37. So we have 37/4 there. Still got division happening. Let's take the 2.5. Let me change up colors here. Let's take the 2.5. We have 2.5. That is equal to 2 times 2 is 4, and 1 is 5 halves. So now we have 37/4 divided by 5 halves. That is going to change into our multiplication problem. And our multiplication problem is going to be 37/4 times 2/5. Remember, we're dividing with a fraction is the same as multiplying by its reciprocal. So we kept the 37/4, changed it to 5/2. That was what we were dividing by, so it changes to 2/5. That's the reciprocal of 5/2. I'm going to do some canceling before I start this multiplying. 2 goes into 2 once. 2 goes into 4 twice. 37 times 1 is 37. 2 times 5 is 10. Again, 37/10 miles per hour. That's not going to make sense to folks, and math is all about communicating. So 37 divided by 10, 3 times with 7/10 left over. And so we would say that his speed was 3 7/10 miles per hour. That would be our final answer. Okay, so now you've seen the two walkthrough problems. There are 6 problems remaining, and I've grouped them with one of each kind and then one of each kind. And what I'd suggest you do is try the problem, and then if you get stuck, you can listen to the whole explanation. I'll explain each one. If you're not stuck, you can just jump to the answer and see if you got it right. And then if you didn't get it right, you can go back and look at steps. So let's go ahead. You're going to now go to this problem, Jane and the paint, and you're going to pause the video so you can work through it yourself. And then once you've worked through it, you can start back up and see how you did. Okay, good luck. So here we go, Jane and the paint. So what we know is Jane used 15 gallons of paint to paint some signs. There were 9 gallons of blue paint, 6 gallons of white paint. And if you put those together, if you put the 9 gallons of blue paint with the 6 gallons of white paint, you get the 15 gallons that Jane had right here. That's important to know, that all the paint is either blue or white. That's what makes the rest of the problem solvable with just that information. So the school asks Jane, they really like the signs, and they say, hey, Jane, paint some more signs for Redwood, would you? And she says, you bet. I'm going to need more paint. I'm going to make the same design I used. I'm going to need more paint. She decides that she needs 25 gallons to paint the new signs. So the first question is, how many gallons of blue will Jane need? If she's going to need 25 gallons of paint, how many gallons of that will be blue paint? So we are going to set up the problem, and we're going to say, all right, here's what we know. In the original design, the amount of blue paint compared to the amount of total paint were 9 gallons of blue for a total of 15 gallons of paint. Remember, it was all blue or white. 9 blue and 6 white to get the 15. Now I know, Jane speaking now, I know that I need 25 gallons total. How much blue will that be? And once again, we have a proportion problem. So we would multiply, and I'll show you 2 ways to solve this. One way is we would do this multiplication. We would do 9 times 25 is equal to 15 times x. 9 times 25, well, every 4 25s is 100, so this is 225 equals 15x. So we have 225 is equal to 15x. We're going to divide both parts by the 15. That's the coefficient of x. That's where we get that big 1 right there. Divide by the 15. 225 divided by 15. I'm going to do that work right over here. 225 divided by 15. 15 into 22 one time. That's 15. That's 75 left over. 15 goes into 75 5 times. That's 5 times 15 is 75, which means that we've got nothing left. So, by the way, 15 squared, 15 times 15 equals 225. That might be a good one to remember. So 15 is equal to x, which means we know, I'm going to get rid of my work. It's a little easier for you. You got more space than I do probably. Let me drop that out of the way right down there. So we know that Jane needs 15 gallons of blue. The second way that you could solve this, probably the way that I would actually solve this, is I would take that 9/15 and I would simplify it. 3 goes into 9 3 times, 3 goes into 15 5 times. I would simplify it even before multiplying, even if it didn't work out, what I'm going to show you next, just because it makes the numbers easier to use. But I used the original numbers just so you'd see where everything came from. Then I would take that 3/5 and I would say, okay, I've got 3/5 is equal to the x over 25. Now, I know these have to be equal, so whatever I multiply by 5 to get 25, which is 5, is what I have to multiply by 3 to get x, because I have to multiply by a 1 right here. It has to be a 1. And 3 times 5 is 15, just like that, 15. So that's the answer to part A, 15 gallons of blue. Answer to part B, how much white paint will Jane need? Well, to do the white paint Jane needs for the sign, the white paint, we're going to take the fact that there are 25 gallons total. We are going to subtract out the 15 gallons of blue, and what's left over is how much white she needs. So she needs 10 gallons of white paint. If we went through this process, set up the proportion, did the cross multiplication, we would also get 10 gallons of white. All right, on to the next problem. Now remember, you're looking at this next problem, and so remember, you're going to read this problem, you're going to try to solve it first, and then you're going to look at the answer. Don't just watch the answers. So Tyler reads 9 3/4 miles in 13 minutes. Wow. I'm a much better mathematician than I am typist or proofreader, apparently. Tyler reads, and I'm even getting that wrong. Tyler reads, okay, you know what, I don't want to do that. On to our next problem. All right, so here we go. Tyler reads 9 3/4 pages in 13 minutes. What is his average reading rate in pages per minute? So we're going to set this up similar to the way that we set up the canoe problem. Actually, it's similar to the way we set up all the problems. We have pages per minute. We know the original information is 9 3/4 pages in 13 minutes. And our question is, how many pages in 1 minute? You notice the process of this doesn't change. I've got to fix my 13. The process doesn't change, just that some of them have fractions in them and some of them don't. Once again, we're looking at what is called a unit rate. When we talk about unit rate, we are talking about how much happens in 1 unit of time, whether it's 1 minute, whether it's the miles traveled in 1 hour, whatever it might be. So we're going to solve this just the way we solved it before. We're going to multiply the 9 3/4 times the 1. We're going to multiply the 13 times the x. This gives us 9 3/4 is equal to 13x. We're going to divide by that coefficient of 13. So we're going to divide both sides by the 13. The reason we divide by 13 is we know what 13x is equal. We want to know what 1x equals. So 1x is equal to 9 3/4 divided by 13. Now, you certainly wouldn't want to tell somebody, hey, Tyler reads 9 3/4 divided by 13 pages per minute. We need to get that down to a more reasonable form of a number. So we're going to do this division. And remember, when we do that division, we don't divide, we multiply by the reciprocal. So we're going to have 9 3/4 times the reciprocal of 13. And I'm going to do this. I'm going to go back here for just a minute. I'm going to write that as a fraction because it's easier to see the reciprocal if they're both in a fraction form. Equals 1/13. Change this to an improper fraction. So 9 times 4 is 36. 36 is 39 fourths times 1/13. Left off the 1 there. You can multiply that starting right out, but you can also do some canceling. 13 goes into 13 one time. 13 goes into 39, 3 times. Now we have 3 times 1 is 3, 4 times 1 is 4. We're in simplest terms. We have 3/4 pages per minute, and that is our final answer. That's Tyler's rate of speed. He reads 3/4 of a page every minute. Okay, let's keep going here. Here we go. We've got Sarah making Rocky Road. And you're going to set this up. You're going to set it up just like we did the others, and you're going to solve it. So why don't you pause the video again, solve it, and then fast forward to the end, check your answer on the problem. All right, so here goes Sarah. She makes Rocky Road using 18 ounces of chocolate, 12 ounces of marshmallows. That's how she gets the 30, the 18 ounces of chocolate plus the 12 ounces of marshmallows gives her 30 ounces of Rocky Road. Everything in the Rocky Road is either marshmallows or chocolate. The first question asks, if Sarah decides to make another batch of this, she makes 55 ounces now. How many ounces of chocolate will she need? That ounces of chocolate is the unknown. It becomes the X. Since this is the chocolate, our first proportion will be what's the amount of chocolate to the total. How much chocolate to total? In the original, it was 18 ounces of chocolate to the total of 30. This time it's going to be some unknown amount of chocolate to the total of 55. As I spoke earlier, I would simplify this. These start to be really big numbers to work with, so I would simplify this. I'd look, is there something that goes into 18 and 30? And I happen to know that 6 goes into 18. It goes in 3 times, and 6 goes into 35 times. So we actually have 3/5 times x over 55. So now our multiplication is much easier. It's 3 times 55 equals 5 times x. 3 times 55, 3 times 50 is 150, 3 times 5 is 15, so that's 165 is equal to 5x. We are going to divide everything by 5. It's the coefficient. It's the thing that gives us that big 1. And so 165 divided by 5, let's do that right up here, 165 divided by 5, 5 goes into 16 3 times, that's 15, 1 left over, bring the 5, 5 goes into 15 3 times again. We know that 33 is equal to x, which means she needs 33 ounces of chocolate. If she's going to make a batch that's 55 ounces in size, she needs 33 ounces of chocolate. Is there a way to check that? You betcha. Remember that simplified fraction we did, that 3/5? 3/5, is that equal to 33 55ths? You bet. 3 times 11 is 33. 5 times 11 is 55. You could have gone back at this step after you simplified and said, well, 5 times what makes 55? 5 times 11. So 3 times that same 11 is what? 33. Now, to get the amount of marshmallows, how many ounces of marshmallows will she need? Well, we know that 55 ounces of this, that's the new total, we know that of that 55 ounces, 33 ounces were chocolate, so that leaves us 22 ounces of marshmallows. And we could look back and say, well, if you've got 22 out of 55, that's 2/5. 2/5 chocolate, 2/5 marshmallows, 3/5 chocolate, 2/5 and 3/5, 2/5 marshmallows plus 3/5, which were chocolate. That gives us 5/5, which is, again, a 1 whole. That's the full batch. All right, on to the last problem. By now, you're probably just looking at these going, wow, I totally get this. I totally have this down now. So, Samira and the bike. Samira biked 7 3/8 miles in 3/4 hours. What was her speed in miles per hour? Since this is miles per hour and this is 3/4, we know that it's going to be faster than 7 3/8. It has to be higher than that amount. So we're going miles in hours. We know that our starting amount is 7 3/8 in 3/4. Oops, excuse me. In 3/4. And we want to know how much that is in 1 hour. So how many miles in 1 hour? And since this gets bigger from 3/4 to 1, we know this is going to get bigger. This is going to be more than 7 3/8. So we do the multiplication. 7 3/8 times 1 is 7 3/8 equals 3/4 times x is 3/4 x. We are dividing both sides by the 3/4. That gives us the big one right here, which leaves us with x on this side, and x equals 7 3/8 over 3/4. That becomes 7 3/8 times 4/3 times the reciprocal. Let's make this into an improper fraction. 7 times 8 is 56, and 3 more makes 59. So 59/8 times 4/3. We can simplify. That becomes a 1. That becomes a 2. We get 59 over 6. 5 times 1, 59. 2 times 3, 6. We don't want to say Samira bikes 59.6 miles per hour. Nobody's going to make sense of that, so we need to do one last step. 59 divided by 6. 6 goes into 59 9 times. 9 times 6 is 54, and 5 6 left over. So we know that her speed is 9 5/6 miles per hour. So there you go. So now you have some problems that you've practiced. You can take a look at the problems on the practice test itself that you took home, and we're also going to discuss those more in class tomorrow. Okay, thanks for watching this video. I hope it helped out.